To illustrate the conversion of a staggered wedge-dash representation into a Fischer depiction, we have here a simple butane derivative that has an orange bromine and a green chlorine attached at C2 and C3. If this were to be drawn on paper, the bromine and chlorine would both be wedges, and they would both be on the same side of the carbon backbone. When the molecule is rotated, it is possible to see the stable staggered conformation and the general direction of both of the halogen atoms. In order to get to the Fischer depiction, we first have to get the carbon backbone in the vertical position by rotation. Viewing as a Newman depiction shows the two halogens are indeed on the same side of the molecule. If we then tilt the carbon backbone away from the Newman depiction, we begin to see where the Fischer picture is coming from. All four carbons are vertical, and the substituents are left and right. At this point we notice a problem. The chlorine is coming out towards us as is required for a correct Fischer structure, however the bromine is going away from us. Something needs to be turned. Since the bromine is pointing in the wrong direction, we have to rotate around the C2-C3 bond to find the correct orientation. This is done here in the same manner as when we generated Newman depictions using the dihedral driver. We can now rotate the C2 to C3 bond to find the correct orientation in which the Br and H on the horizontal axis are coming out towards us. If we now rock the molecule backwards and forwards, we see that all of the atoms on the horizontal axes are now pointing in the same direction and out towards us as is required by Fischer. Doing this also reveals that the Fischer structure is really an eclipse Newman depiction. Finally, if we move the Fischer depiction in different directions, we see the outcome of the overall manipulation from the wedge-dash depiction. Notice that both halogen atoms are now on opposite sides of the carbon framework, whereas in the original wedge-dash picture they were on the same side. This is a consequence of the rotation around C2 and C3.